In this video, we're going to work through several examples on the worksheet Transparency 1, Formulas and Compounds. So first off, the one I want to do is letter A, calcium chloride. The first thing that I'm going to look up on our periodic table is calcium. Calcium is in column 2A, so it has 2 valence electrons. It's a metal, so it's going to lose those 2 valence electrons, and calcium would become a Ca with a 2 plus. Chloride, the first thing that I recognize is that it ends in IDE. That's my clue to me that it came from the periodic table. It's an element from the periodic table. When I look up Cl, it's in column 7A. That indicates to me it has 7 valence electrons, and it wants to gain 1 valence electron to become a Cl minus. The 2 plus and the 2 minus do not cancel out. I need another Cl with a minus. Now the 2 plus and the 2 individual minuses cross out, and we are left with the formula of 1 Ca with 2 Cls. The final formula does not have any pluses or minuses in it because it cancels out. It also doesn't have any subscripts. Subscripts are used for positives and negative. Superscripts are used for positives and negative. Subscripts are to identify the number of elements that we have. Since we have 1 Ca, there's an invisible 1 there. The next one I would like to do is letter B, magnesium carbonate. When I look up magnesium on the periodic table, it's also in column 2A, so it has 2 valence electrons, so it'd be Mg with a 2 plus. The one thing I want you to notice about carbonate is it ends in ATE. This is a clue to me that I am not going and looking for somebody like carbon on the periodic table. Because it ends in ATE, I am looking for a polyatomic ion. And when I look up carbonate, it's 1C with 3 O's. The subscript tells me how many there are. And that 1C with 3 O's is a 2 minus charge. So 1C with 3 O's that has a 2 minus charge. 1 Mg gives you a 2 plus. One group of CO3 give you a 2 minus. So it's simply MgCO3. If I would have had more than one polyatomic ion, I would have needed to put parentheses around it with a subscript on the outside. Let's look at that type of example. Aluminum nitrate. Aluminum is in column 3A. Because it's in column 3A, it forms a 3 plus. It has 3 valence electrons. So we write it as Al 3 plus. When we look at nitrite, what I want you to notice is it ends in ITE. Remember, if it's an element from the periodic table, it would end in IDE. Nitrogen would be nitride, not nitrite. Because it's nitrite, we look on the back side of our periodic table, and nitrite is NO2, 1 N and 2 O's, a group of NO2 with a 1 minus charge. So 1 N with 2 O's and a 1 minus charge. Notice the 3 plus does not balance the 1 minus. The superscripts are for charges. The subscripts are for how many we have. So I need another NO2 grouping with a 1 minus. And yet I need another NO2 grouping with a 1 minus charge. I need 3 groupings of NO2 with 1 minus each to match. So when I write the formula, there is 1Al, but because there are 3 groupings of NO3, I have to put, 3 groupings of NO2, I have to put NO2 in parentheses, and then because there are 3 groupings of them, I put a 3 as a subscript. It's a grouping of NO2 that has a 1 minus charge, but because there's more than one grouping of them, we have to put the parentheses around the NO2 and the number that we have, and there are 3 of them. The next one I would like to do is potassium hydroxide. Now this one's tricky because it does end in IDE, which makes us think that it must have come from an element on the periodic table. Maybe hydroxide is just hydrogen turning into hydroxide. But there are 3 that are tricky that end in IDE. One of them is cyanide. It's a polyatomic ion. One is hydroxide. It's a polyatomic ion. And one is peroxide. It's a polyatomic ion. Those 3 are tricky. So potassium is in column 1A, so it becomes a K with a 1 plus. But hydroxide, we need to remember that that's one of those that comes from the polyatomic ion OH with a 1 minus. The OH with the 1 minus balances the K with the 1 plus, so it's simply KOH. Let's take a look at letter D. Letter D shows a Roman numeral inside of the name. Why would there be a Roman numeral inside of the name? Well, when we look up iron on the periodic table, we will notice that iron is in the transition metal section. It's not in an A column. Because it's not in an A column, we can't just slide up and see what kind of charge it is. 1A, 1 plus, 2A, 2 plus, 7A, 1 minus. Fe is a transition metal, so we don't know what kind of charge it is. The only way we're going to know what kind of charge it is by going to the oxidation state chart. But the issue with the oxidation state chart is when we look up Fe, most of these transition metals will have multiple options, and one of the options for Fe is a 2 plus or a 3 plus. So because it can be a 2 plus or a 3 plus, we don't know which one it is. So its name will have to tell us what it is. So because it's listed as iron 2, we know it's going to be Fe with a 2 plus. So now we look up sulfate. Notice the ATE. So on the back of our periodic table is our polyatomic ion chart. Sulfate, a group SO4 with a 2 minus charge. SO4 with a 2 minus charge. The charges cancel out, 1-to-1 ratio, so it's simply FeSO4. This charge refers to this charge. This Roman numeral refers to the charge on the metal. So now let's take a look at nickel 2 phosphate. When I go look up nickel on the periodic table, nickel is a transition metal, and there are multiple options that nickel can have, a 2 plus or a 3 plus. In this case, we know it has to be a 2 plus because of the Roman numeral 2. Phosphate ends in ATE, so I know I'll go to the back of my periodic table. Phosphate, PO4, a grouping of PO4 with a 3 minus charge. A grouping of PO4 with a 3 minus. A 2 plus and a 3 minus do not cancel out, so I just start putting down until they cancel. Now a 4 plus with a 3 minus, they still don't cancel out. Now a 6 minus with a 4 plus, they still don't cancel out. It's going to take 3 NIs for 2 PO4s. So I need 3 NIs. Ni is not a polyatomic ion, so I do not need parentheses around him. So Ni3. But I do need parentheses around the PO4. I have a PO4, and there are 2 of them, so Ni3 PO4. Notice the Roman numeral does not go in the formula. The Roman numeral only goes in the name. So let's take a look down on the bottom. Let's take a look at CuSO4. How do we figure out the name of CuSO4? Well, Cu, when I go to the periodic table, I find Cu in the transition metal section, and it can have multiple charges. So at this point, I do not know what the charge is on Cu, so I leave it alone. The next is SO4, a grouping of SO4, and there is only one grouping of SO4. SO4 is a polyatomic ion, so I look it up. Sulfate, it's a 2-. So I put down 2-. Now notice, in this formula, there's one Cu and one SO4. So if there's one Cu and one SO4, that means the Cu must be a 2+ charge. So now, because copper can have multiple charges, I need to identify that when I name it. And I'm actually going to name it down here. I'm going to name it copper. And because it can have multiple charges, I have to use a Roman numeral 2 for the charge to identify it. And it's copper 2 sulfate. For the last example, let's look at zinc and then nitrate. I'm going to write down zinc. When I go find zinc, it is in the transition metal section, but it's unique in that it can only have one charge. It can only be a 2+. So Zn is a 2+. I don't have to wait to put the charge down like I did for copper, because zinc only has one option. So we write it as a Zn 2+. If it had multiple options, we would have to wait to put the charge. NO3, when I look up NO3 on the polyatomic ion chart, it's an NO3 with a 1- charge. So I need another NO3 with a 1-. This is why the formula was 1 Zn with 2 nitrates. When I write the name, it's zinc, but remember, zinc only has one option of a charge. So I do not put the Roman numeral. Even though it's a transition metal, if there is only one option, we do not include the Roman numeral. So it's simply zinc nitrate, ATE. I hope this helps with finding the formula once we are given the name, both with the standard ionic compounds, with polyatomic ions, as well as transition metals, and moving from the formula to the name using Roman numerals.